Hello students, in the earlier session we have studied the concept of parallel lines. In this session we are going to learn about the properties of parallel lines. The first property is named as interior angle theorem. Now let us have the statement of the theorem. If two parallel lines are intersected by a transversal, the interior angles on either side of a transversal are supplementary. We will try to understand this theorem diagrammatically. For that, let us consider two parallel lines, line L and line M. These two lines are parallel. And if there is line N, which is a transversal of these two lines, then we have four angles, angle A, angle B, angle C and angle D, formed at two distinct points where line N intersects line L and M respectively. Here angle A and angle B are interior angles which are on the same side of a transversal. So by this theorem we have angle A plus angle B is equal to 180 degree, as interior angles on the either side of a transversal are supplementary. Similarly, the another pair of interior angles, that is angle C and angle D, is also supplementary. That's why angle C plus angle D is equal to 180 degree. By using the previous theorem, we can have the another property of corresponding angles theorem. The theorem is the corresponding angles found by a transversal of two parallel lines are of equal measure. So again, to illustrate this, let us consider a diagram in which we have two parallel lines, line L and line M, and line N is their transversal. So in diagram we have got three angles, angle A, angle B and angle C, out of which angle A and angle B are the corresponding angles. Now we have to prove this theorem. So for that, given is line L is parallel to line M and there is line N which is the transversal of these two lines. And we have to prove that the corresponding angles so formed are congruent, that is angle A is equal to angle B. So to start with proof, we have the first pair, that is angle A plus angle C is equal to 180 degree, as these two are angles in linear pair, and as we know, angles in linear pair are supplementary. That's why we have written here angle A plus angle C is equal to 180 degree. Now the second statement is angle B plus angle C is equal to 180 degree, because angle B and angle C are the interior angles, and if two lines are parallel, then the interior angles are supplementary. If we consider these two equations, we can observe right hand sides are equal, so the left hand sides must be. So angle A plus angle C is equal to angle B plus angle C. On both the sides, angle C will get cancelled, so as to get angle A is equal to angle B. Hence the proof of corresponding angles theorem. Now the next theorem is alternate angles theorem. Let's have the statement of alternate angles theorem. The alternate angles formed by a transversal of two parallel lines are of equal measure. Now we have to prove the alternate angles theorem. So for that, let us consider a diagram. Suppose there are two parallel lines, line L and line M, which are parallel, and line N is their transversal. And due to this transversal, angle B, angle C and angle D are formed at two distinct points. So here the given will be line L is parallel to line M and N is their transversal, and we have to prove that angle D is congruent to angle B, as these two are alternate angles of each other. We will start with the proof. Angle D plus angle C is equal to 180 degree, as these two are angles in linear pair, and we know that angles in linear pair are supplementary. That's why sum of their measures will be 180 degree. The second step, we have angle B plus angle C is equal to 180 degree, as angle B and angle C are the interior angles, and we know if two lines are parallel, their interior angles are supplementary. So these are the two equations. From these two we can conclude, as the right hand sides are equal, so the left hand sides must be. That is, the left hand side of equation 1 is angle D plus angle C, which is equal to the left hand side of equation 2, that is angle B plus angle C. On both the sides we have angle C which will get cancelled each other to get angle D is equal to angle B, which are alternate angles of each other. So here also we have proved the theorem by using interior angles theorem. So by these three theorems we can conclude that if two parallel lines are intersected by a transversal, then the corresponding angles formed are congruent. Alternate angles formed are also congruent, and interior angles formed are supplementary. So these are the properties of parallel lines. That is, if two lines are parallel, then we have these properties. Now suppose we are given two lines and we have to decide whether these two lines are parallel or not. We have to use some test, and first test is interior angles test. Let's have the statement of the theorem. If interior angles found by a transversal of two distinct lines are supplementary, then the two lines are parallel. Now in this theorem it is not given that two lines are parallel, but instead we have to prove that the given two lines are parallel. So for a diagram, let us consider any two lines AB and CD, and let line XY is their transversal. Here line XY intersect line AB and line CD at points P and Q respectively. So line XY is the transversal of line AB and line CD, and if the measure of angle BPQ plus measure of angle PQD is equal to 180 degree, that is, if these two angles are supplementary, then from this we can conclude that the given two lines, line AB and line CD, are parallel. So this is interior angles test by which we can decide whether the two given lines are parallel or not. In short, if interior angles are supplementary, then the two lines are parallel. Now the next test is alternate angles test. Let us have the statement. If a pair of alternate angles formed by a transversal of two lines is congruent, then the two lines are parallel. Now unlike the interior angles test, for alternate angles test, those two alternate angles must be congruent. Now for that, let us consider any two lines AB and CD. Line XY is the transversal which intersect line AB and CD at points P and Q. Now in this case, if angle APQ is congruent with angle PQD, which are alternate angles, then from that we can conclude that the given two lines, that is AB and CD, are parallel. That is, line AB is parallel to line CD. In short, if alternate angles are congruent, then the given lines are parallel. Now consider the next test, that is corresponding angles test. Let us have the statement. If a pair of corresponding angles formed by a transversal of two lines is congruent, then the two lines are parallel. It is similar with the previous one. Let us consider any two lines AB and CD. Let XY be the transversal which intersects the two lines at point P and Q. Here we have to decide whether line AB is parallel to line CD or not. So if XY is the transversal, and in this case if angle XPB is congruent with angle PQD, which are corresponding angles. So if this is the case, then from that we can conclude that the given two lines, that is AB and line CD, are parallel to each other. That is, line AB is parallel to line CD. In short, if a pair of corresponding angles is congruent, then the given two lines are parallel. So these are the three tests by which we can decide whether the two lines are parallel or not.